Dear students, today we will discuss about the topic called polarization. Coming to the definition of the polarization, polarization is related to the electric field intensity. The definition of the polarization is nothing but orientation of the electric field intensity with respect to time at a fixed distance. It is defined as orientation of the electric field intensity with respect to the time at a fixed distance. Now we can write a definition: orientation of E with respect to time at a fixed distance or a fixed or constant distance. We have three types of polarization. First one is linear polarization. Linear polarization. Second one is circular polarization. Circular polarization. And third one is elliptical polarization. We will see these types of polarizations one by one. Coming to the linear polarization, first one is linear polarization. So linear means we know that straight. So like this horizontal straight line, and it is vertical straight line. This one is linear polarization. This one is also linear polarization. And next here, this indicates horizontal polarization. Suppose if the field is like this, if electric field traces a straight line like this is vertical polarization. If electric field direction is like this, so this one is known as theta polarization. This one is known as what? Theta polarization. Means here, if Ex is present, means electric field is along horizontal direction, means Ex is not equal to 0 and Ey equal to 0. This type of polarization is known as horizontal polarization. Horizontal polarization means electric field is along x direction, that is Ex is not equal to 0 and electric field along y direction is 0. So that type of polarization is known as what? Horizontal polarization. Next, vertical polarization. If the direction of the electric field traces a straight line like this and Ey is not equal to 0, Ex equal to 0. If electric field is present along y-axis and it is not present along x-axis, then this type of polarization is known as what? Vertical polarization. Vertical polarization. Next, this one, here we have electric field along x direction. It is not equal to 0 and electric field is along y direction. Then resultant field is equal to what? The magnitude of resultant field, that is equal to under root Ex square plus Ey square. Means here both electric field present along x direction and y direction, but resultant field is like this, and the angle between x and y is this angle is this angle, that is theta, or this one is 90 minus theta, where this theta is not equal to 90 degrees, not equal to 90 degrees. That type of polarization is known as what? That type of polarization is known as what? Theta polarization. Theta polarization. So these are the different types of the linear polarization. Horizontal polarization means what? X component is present, that is Ex is not equal to 0, Ey equal to 0. Vertical polarization means what? Ey is not equal to 0, means Ey is present, electric field along y direction present, and electric field along x direction is 0. Coming to the theta polarization, both Ex and Ey are present, and here the angle represented in the diagram, that is theta. Theta is not equal to 90 degrees. That type of polarization is known as what? Theta polarization. Now coming to another polarization, that is what a circular polarization. Circular polarization. Reference at the center of the circle. Here we have the electric field along x direction and electric field along y direction. Ey and Ex. The angle between Ey and Ex is what? 90 degrees. So this type of polarization is known as what? Circular polarization. Simply, direction of E traces a circle. If direction of E traces a circle with respect to time, that type of polarization is known as what? Circular polarization. Or else, we can define this one in terms of Ex and Ey also. So, coming to the definition of circular polarization in terms of Ex and Ey, if Ex and Ey are present, Ex is not equal to 0 and Ey is not equal to 0, both are present, and angle between, that is theta, let us say theta, okay, between Ex and Ey equal to 90 degrees. That means the phase difference between Ex and Ey equal to 90 degrees. That type of polarization is known as what? Circular polarization. Questions for the Ex and Ey in terms of time domain is Ex and Ey. So for lossless medium, we can write E naught cos of omega t minus beta z. And Ey can be written as what? As amplitudes are equal. That is what? E naught cos of, okay, that is Ey. We can write 90 degrees phase difference means what? Sine of omega t minus beta z. Sine of omega t minus beta z. One is Ey, and I am taking now like this. We have the circle equation, that is x square plus y some a square, that is constant square. Okay, x square plus y square equal to a square. That indicates what? A circle A center at a origin. Here also, if you take, instead of taking x square, let us take ex square, and plus ey square. Let us simplify this one. Let us simplify this. Ex square means what? E naught square cos square of omega t minus beta z plus E naught square sin square omega t minus beta z. Of course, we can take z at a fixed distance. Let us say z equal to 0, or else anything. Or else, let us assume, let us put as it is. So here you can take E naught square as common. Cos square omega t minus beta z, that is, let us say theta. And this one is sin square theta. Finally, we got E naught square, which is equivalent to what? Ex square means x square plus Ey square, that is component along the y axis, that is y square, is equal to some constant square, that is E naught square, which represents what? A circle. So this type of polarization is known as what? Circular polarization. Again, in circular polarization, we have right hand circular polarization and left hand circular polarization. So let us see this left hand and right hand circular polarization. So this is one circle and this one is another circle. So let us take this one, and here x and y are equal. So means this one is Ex and this one is Ey. Let us take this as RHCP, and this one is what? LHCP. If Ex is leading, if Ex is leading, Ex is leading, sorry. Ex is leading means what? First Ex starts, then Ey starts. First Ex starts, then Ey starts. So that type of polarization is what? Known as what? Right hand circular polarization. So in the previous case, we have taken what? First EX starts. EX starts means EX leads. EY follows this one. So this one is a right hand circular polarization. Next, coming to the EY starts. Y. So Y like this. So like this. EY started and then after EX follows that one. So this is known as what? Left hand circular polarization. Left hand circular polarization. Coming to the elliptical polarization. Elliptical polarization. Only one difference between circular polarization and elliptical polarization. So here Ex is the magnitude of Ex is equal to the magnitude of Ey. They are equal in magnitude. I forgot to this point in the circular polarization also. Both Ex and Ey are present. They are equal in magnitude. They are equal in magnitude or amplitude. So that's why I have taken E0 and E0 here. Whereas coming to the elliptical polarization, Ex and Ey are not equal. The magnitudes are not equal. Let us say Ex magnitude is equal to Ea. It is equivalent to Ea. And Ey magnitude is Eb. They are not equal. They are not equal. And phase difference between them, that is the angle between Ex and Ey is theta, that is equal to 90 degrees. Phase difference is 90 degrees, but they are not equal in magnitude. Now, let us see the equation of ellipse. So actually, we have equation of ellipse is what? X square by a square plus y square by b square is equal to 1. If you take x component, that is Ex component and Ey component, we have to get this ellipse equation. Okay, ellipse equation is like this. So now we will prove according to definition, we have to get the ellipse equation only. So let us take Ex. Ex is present and Ey both are present. They are not equal in magnitude. Ex is equal to what? Ex is equal to Ea amplitude as Ea. For this one, amplitude or magnitude is Eb, cos of omega t, and Ey is what? There is a phase difference of 90 degrees. So that's why here, as it is cos omega t, it can be taken as what? Sin omega t. Of course, cos of omega t minus beta z. Cos of omega t minus beta z. Here also omega t minus beta z. At z equal to 0, at a fixed distance, at z equal to 0, fixed, we can take any value, okay? So then you have what? Ex is equal to at a z equal to 0, Ex equal to Ea cos omega t. Ea cos omega t. Ey is equal to what? Eb sin omega t. Eb sin omega t. Now I am writing this one, that is Ex by Ea is equal to cos omega t. From this Ey by Eb, Ey by Eb is equal to what? Sin omega t. So therefore, I am taking whole square on both sides. Ex by Ea whole square, which is equivalent to what? Cos square omega t. Cos square omega t. I am adding this Ey by, let us take Ey by Eb whole square also and add the term to this term, Ey by Eb whole square. Then we have what? Sin square omega t. Why I have done like this? Because we have the equation of ellipse. What is that? X square by a square plus y square by b square is equal to 1. We have to get like this. X square means what? This one, Ex square. And let us add E to these terms. So that is what? X square, for instead of x square, we have Ex square. And EA square means what? A square means what? EA square. Instead of having EY square, okay, instead of having Y square, here we have taken EY square. And next, instead of B square, we have taken EB square. So therefore, from this, we have what? From this, what we have? EX square, EX by EA square means here EX square I'm changing the color. Okay. What we have? E x by EA whole square. I am writing that one as what? EX square by EA square, left side. And EY by EB whole square can be written as what? EY square by EB square. And this one is what? Cos square omega t plus sin square omega t. Nothing but what? Cos square theta plus sin square theta, which is equivalent to what? 1. So this one is nothing but what? Ellipse equation only. This one is nothing but what? Ellipse equation. So this one is elliptical polarization. Means elliptical polarization is defined as what? Ex is present and Ey is present, but their magnitudes are not equal and phase angle difference is 90 degrees. Then the type of polarization is known as what? Elliptical polarization. Coming to circular polarization, only difference is what? Here Ex equal to G, Ex, magnitude of Ex equal to magnitude of Ey. For the circle, if you take from the center point, it indicates what? Ex. It is nothing but radius of the circle, and it is what? Ey. So they are equal in magnitude for this circular polarization. Whereas coming to the elliptical polarization, I am drawing an ellipse. So here, coming to the center point of view, here this one is, let us take this as Ex, and it is what? Ey. Here Ex is not equal to Ey. As we have in case of the circular polarization, we have right hand circular polarization, left hand circular polarization. Here also we have what? Right hand elliptical polarization, right hand RH. Elliptical polarization means EP. Right hand means what? Ex is leading. Ex is leading. Then Ey started its journey. So this type of polarization is known as what? Right hand elliptical polarization. Coming to left hand elliptical polarization. So ellipse. This one Ex, and this one Ey. Ey starts its journey. Then after Ex follows that one. So this one is what? Left hand circular polarization. If you stand in front of this one and if you rotate your hands, okay. So this one is aligned with your left hand. The direction is aligned with the left hand. And if you stand here and if you rotate your hands, this one is the direction. In this case, the direction is indicated by arrows. So this direction is aligned with your right hand. So that is right hand elliptical polarization. So this is about polarization. So in today's class, what we have discussed? Polarization. What is meant by polarization? Polarization is nothing but orientation of the electric field with respect to time at a fixed distance, or changing the direction of the electric field with respect to time at a fixed distance. So what are the types of the polarization? Linear polarization, circular polarization, elliptical polarization. Linear polarization means what? If the direction of the electric field with respect to time traces a straight line, that may be horizontal or that may be vertical or it may be some slant line, a straight line. So that type of polarization is linear polarization. Coming to the circular polarization, in circular polarization, if the direction of the electric field traces a circle with respect to time at a fixed distance, that type of polarization is known as what? Circular polarization. In circular polarization, both Ex and Ey are present. The magnitudes of Ex and Ey are equal and phase difference between them is 90 degrees. Coming to the elliptical polarization, only one difference compared to the circular polarization. Ex and Ey are present, but their magnitudes are not equal. Phase difference is 90 degrees as in the circular polarization. So this is about polarization. Okay, we will meet in next class. I will share the YouTube link within 5 minutes for the next class. Thank you.